Hi everyone. So my name is Adbucha Godfred, an electrical engineering student of Accra Technical University, and as part of my C++ course, I'm supposed to build a project for monitoring electrical loads. And in this video, I'm going to explain how the project works. So the program shown is a C++ electrical load monitoring and billing system designed to help users record electrical appliances, estimate the daily electricity consumption, and calculate the cost of electricity usage based on a given tariff. It also saves appliance information and billing summaries into files so that the data can be reused later. The program demonstrates important programming concepts such as structures, arrays, functions, file handling, input validation, and loops. At the beginning of the program, several header files are included, which are IOStream, FStream, strings, IO main IP, and limits. These libraries provide different functionalities needed by the program. For example, the IOStream allows the program to receive input from the user and display output on the screen using cin and cout. Also, the FStream libraries enables the programs to read and write the files. The string library makes it possible to store and manipulate text, whilst IO man IP helps format output neatly using features like set precision and set W. The limit library is used to handle input errors and clear unwanted data from the input buffer. The statement using namespace std allows the program to use standard library functions without writing std semicolon before them. Also, the program defines constant variables that store the name of the files used in the system. These include appliances.txt, which stores appliance information, and billing_summary.txt, which stores billing records. Another constant called max_appliances sets the maximum number of appliances that can be stored in the system to 100. Using constant ensures that these values remain fixed throughout the program. The program then defines a structure as called appliance, which represents electrical appliances entered by the user. The structure contains three variables, that is the name of the appliance, its power rating in watts, the number of hours it's used per day. While structures also allow the program to group related information together, making it easier to manage and store appliance data. Also, several helper functions are included to make the program more reliable and user-friendly. So, for instance, the flash input bracket function clears the input buffer to prevent errors when users enter incorrect data. The trim text bracket functions removes unnecessary spaces from the text entered by the user, while the to lower text bracket functions convert text to lowercase so that searches can be performed without worrying about uppercases or lowercase later. The program also includes input validation functions such as getInt bracket, getDouble bracket, and getNonEmpty lines. These functions ensure that the user enters the correct type of data. For example, getIn repeatedly asks the user to enter an integer until a valid number is provided, whilst getDouble ensures that decimal numbers are entered correctly. The getNonEmpty line function ensures that the user does not leave important text fields empty. And also, the system performs energy consumption calculations using specific functions. So the function calculation kilowatts per day calculates the daily energy consumption of a single appliances. The formula used is power in watts divided by 1000 multiplied by the number of hours used per day. This converts watts to kilowatts and determines how much electricity the appliance uses daily. Another function to calculate total kilowatts per day adds the energy consumption of all the appliances in the list to determine the total daily electricity usage. The program also includes file handling functions to store and retrieve data. The save appliance file function writes all appliance information to the file appliances.txt, separating the appliance name, watts, and hours with a vertical bar symbol. This allows the data to be saved permanently so that it can be used again later. The load appliance file function reads the saved appliance data from the file when the program starts. It processes each line, extracts the appliance information, converts text to numbers when necessary, and stores the values in an array. Another important file operation is performed by the appending bill summary function. This function also saves a summary of billing calculations to the file billing_summary.txt. The summary includes the tariff rate, the number of appliances, the total daily energy consumption, the daily cost, and the daily estimated monthly energy usage and cost. The program also provides several main features that the user can access through a menu. So the show menu displays the available options such as registering a new appliance, viewing the appliances, searching for an appliance, calculating billing, saving data to a file, or exiting the program. The register appliance function allows the user to enter the name, the watt, and the daily usage hours of an appliance. Once entered, the appliance is stored in the system and saved to the files. The view appliances function displays all stored appliances in a neatly formatted table showing their details and their daily energy consumption. The search appliance function allows the user to search for all appliances by name. It compares the search text to appliance names and display anything matching results. Finally, the program executing begins in the main function. An array of appliances is created to store the appliance records, and the program attempts to load any previously saved appliance from the file. After displaying a welcome message, the number of appliances loaded, the program enters an infinite loop that repeatedly shows the menu and waits for the user to choose an option. So depending on the choice, the corresponding function is executed or sorry. So as I was saying, after displaying a welcome message and the number of appliances loaded, the program enters an infinite loop that repeatedly shows the number and waits for the user to choose an option. So depending on the user choice, the corresponding function is executed. If the user chooses to exit the program, the appliance data is saved, a goodbye message is displayed, and the program terminates. So in conclusion, this C++ program is a practical example of how programming can be used to manage and analyze electricity usage. It allows users to record appliances, calculate energy consumption, estimate electricity cost, and store data for future use. The program effectively also demonstrates important programming techniques such as structured data, file management, user input validation, and modular programming through functions. Thank you very much.